Here we go again. Today we're going to figure out just how overpowered is the Pythagorean theorem. Is the Pythagorean theorem an overpowered theorem? And are nerfs incoming? To remind ourselves, the Pythagorean theorem is a squared plus b squared equals c squared. The square of the legs summed together will equal the square of the hypotenuse. Let's check out Pythagorean theorem and its uses. Given two of the three sides of a right triangle, we can use the Pythagorean theorem to solve the third side. We are given the base of the triangle, one of the legs, to be 3. We're given the hypotenuse of the triangle, because it's the longest side for our right triangle, to be 5. Our job here is to figure out the height of this right triangle or the second leg. Using Pythagorean theorem, we have a squared plus b squared equals c squared. We know our a is 3, so we're going to have 3 squared plus our unknown b value being squared. So our b will be just b squared. Then this is equal to our c value squared. And we know our c given to us to be 5. We'll simplify the left side, giving us 9 plus b quantity squared is equal to 25. Then we'll subtract 9 to both sides of our equation so that we'll have b squared is equal to 25 minus 9 is 16. Then our last step is to square root both sides. So if we square root both sides, we'll end up with our b value equaling 4. So the missing height is 4 units. And that's the straightforward use of Pythagorean theorem. Just nice and simple and easy. Now let's gauge the level of easiness. So the ease of use level is 10 out of 10. Pythagorean theorem and history. Ancient civilization. Babylon. Around 1900 to 1600 BCE. The earliest known reference to Pythagorean theorem comes from the ancient Babylon tablets. Ta-da! The Plimpton 322 tablet, dating around 1800 BCE, shows Babylonians had knowledge of Pythagorean triples. Pythagorean triples are whole numbers that satisfies the theorems. We can expand Pythagorean triples infinitely. They look like tiny little spaceships that go on forever. More Pythagorean history. Part 2. Time to talk about the Greeks. Around 570 to 300 BCE to today. One of the most significant contributions came from Euclid, who included a proof of the theorem in his influential work, Elements, around 300 BCE. Euclid proof continues to be studied by students and scholars today. So in the Elements, Euclid did a proof that looks something like this. Now we'll check out the historical level meter. Historical level is 10 out of 10. Pythagorean theorem is foundational, and Pythagorean theorem is considered one of the oldest theorems. And we still use it today. Woohoo! Pythagorean theorem and applications in other theorems. We're going to prove the law of cosine. If we have the following triangle, A, B, and C, then we're going to draw the apothem or the height from A all the way down to segment BC. We'll get the intersection of segment BC at some arbitrary point H, creating a right triangle. We want to first focus on the left right triangle and look at the height that we're going to label little h. We're going to use some basic trig identity, don't forget SOHCAHTOA, and set up the sine of angle C. So the sine of angle C will equal the opposite over the hypotenuse. In this situation, it will be the height over the hypotenuse of little b. We'll solve for the height and we'll get h is equal to b times the cosine of c. We'll replace the height with b times cosine of c, and now we'll look at the segment from c to h. So this time we're going to use the cosine of angle c. With the cosine of angle c, that will equal the adjacent over the hypotenuse, which will be segment CH over the hypotenuse B. We'll solve for the segment C to H, and that will equal B times the cosine of angle C. We'll replace the base of the left triangle, the triangle A, H, and C, with B times the cosine of C. This will divide the length of B to C into two parts. So we'll redefine the segment A. So segment A is A plus cosine of C plus A minus B times the cosine of C. We now want to start focusing on the right side of the triangle, which we're going to focus on A minus B times the cosine of C. Now that we're focusing on the right side of the triangle, we can slowly remove the information of the left side triangle. On the right, we want to focus on the height, which is B times cosine of C, and the base, which is A minus B cosine of C, and the hypotenuse, the length of little c. Here we go. Now we're going to use Pythagorean Theorem into our right-sided triangle, where, remind ourselves, the hypotenuse squared is equal to the base squared plus the height squared, or the hypotenuse is the square of the sum of the square of the lengths. So we're going to take the base here, or leg of A, and substitute it into the first sum squared. Then we're going to take our height value that we're going to replace with B, and we're going to square that. Bloop, bloop. There it is. Using some more algebraic and trigonometric identity, we'll be able to simplify our equation to c squared equals a squared plus b squared minus 2ab times the cosine of c. And here's the theorem or the formula for law of cosines. So the application level of Pythagorean Theorem is 10 out of 10. It's used to prove other theorems and formulas. Speaking of proofs, for Pythagorean Theorem, there are over 400 known proofs today. That's crazy! Let's refer back to one of the proofs we talked about earlier, the Euclidean proof from the Elements book. Proposition 1, number 47. The first part of the proof requires us to construct parallel lines. The second part will require us to construct congruent triangles. And the last part will figure out how to do areas of parallelogram. That's the brief Euclidean proof in the Elements for Pythagorean Theorem. Here's another one. Using areas of triangles, we can create a square, cut it up into 4 triangles with another square on the inside, and we'll be able also to prove Pythagorean Theorem this way. Another proof for Pythagorean Theorem uses geometry, where the areas of the square built on the side of a right triangle is compared. This is one of the more classic examples of using areas to show Pythagorean Theorem works. We'll have the area of the square A plus the area of the square B, and that'll equal the area of square C, proving Pythagorean Theorem. It's ridiculous how many proofs there are for Pythagorean Theorem. Pythagorean Theorem might actually be one of the most proven theorems of all. It has the proof level of 10 out of 10. It's crazy. Before we get to our final verdict, don't forget to like and subscribe. Let's continue to the actual tier list now. What do you think Pythagorean Theorem will be placed on the tier list? Hopefully it's pretty obvious. It should be S tier. It's ridiculous. Everything has 10 out of 10. But that's it for now. When we come back, we'll maybe do some more ratings. And that's the end of our short break. Woohoo! However, like and subscribe. I'll see you back for next time.